And this microphone works.
And now this one works magically. Okay. I think my microphone is working now. I do believe it is. At least my camera is working. Yeah, it looks like it's working. All right. Let me not complain about streaming software because lately I've been doing that every single time I start a stream for good reason, but still. Okay. Instead, today I am working on my compiler because yesterday I was able to fix some issues with it. And I just need to see what I need to sync. Okay. Well, most likely need to download a bunch of changes from various projects. Or not. This one's called radxlib. Alright, that one I needed to download. Then make clean and then make. And finally the compiler itself. Up to date. Apparently up to date. Okay. Yeah, everything's up to date, it seems. So, does this work? I forgot. It looks like it's working. Okay. So I fixed some things in my compiler. And it's actually able to parse things even better than before now. It looks the same, but yeah, it works better than before. And okay, I was a little bit confused by my code, but kind of hacked it together a little bit. I added -nl as a command line tool to the compiler so that you can specify if you want it to be new line sensitive or not. Since the point of this compiler is to compile any language that you specify with this little set of rules right here. So these get parsed by this little parser compiler thingy. And actually I made it so that it directly, when it outputs something, it writes it directly to the rules.c file into this array. And then that gets picked up by the main compiler, and then it gets parsed. It does semantic analysis, and it does some very basic code generation, but I want to expand that a little bit. By a little bit, I mean a lot, because like I said, very basic code generation. Okay. So cred.elf, and for example, right now it scanned this very simple subset of C kind of program, and then it parsed it, so parsed it correctly, did some semantic analysis on it, detected the declaration of a y, x, a y loop, and x loop symbols. And then what it does is it just generates code based on these same rules. So essentially, wherever I detected a scope, a block that's made up of a statement and another block, then I will output a statement, which is a declaration, which is made up of an identifier, another identifier, an equal sign, an expression, and a semicolon. And that's literally what it outputs. Identifier, identifier, equal sign, expression, semicolon. And that's what it outputs here. So that's cool if the point of your compiler is to get the same input, the same output that it got as an input, except poorly formatted. I don't think that's anyone's goal as a compiler. I mean, you do have some tools that do parsing and semantic analysis, like static analyzers and whatnot. And even LSP, well, LSPs don't really work like that, but they, you know, they rely on that kind of functionality without actually generating code. But then you just skip the code generation. You don't just generate the same code you got in. So having this is useful to test that the compiler is correctly understanding the code that it is reading, but it's not really useful for doing anything with that code. Hi, Amix. Stream just started. All right. So yeah, outputting the same code that you get as input, but formatted poorly. Not exactly my idea of a useful compiler. Don't know about anyone else, but personally not my idea of that. So I'm thinking today I want to work a little bit on the code generation, which is really the one part of the compiler that isn't built on a basic level, you know. The compiler's like 2 weeks old. You don't hear something, meaning what? Wait, is my microphone working correctly? Because I think it is, but it was having issues before. So I'm not entirely sure. I'm scared that you're not saying anything. Hey, Goldfish. Alright, I'm just gonna listen to it real quick to make sure that it does work. And while I was talking, I was putting these headphones away. Now I have to roll them out again. Alright, let me see. Alright. No, I do hear myself just fine. And actually the headphones did nothing because it still played off my speakers. But yeah, volume is fine. As far as I can tell anyway. YouTube broke. Well, we're very shocked by this news. Alright. Here's the thing. Alright. This compiler, like we said last time that I worked on it, I believe it was, that we talked a little bit about this, is not the most efficient. And it definitely isn't going to be the clearest when it comes to giving you error messages. It's just going to tell you, hey, you have an error here. And it's not going to tell you what the error is, most likely. Because it's not... how do I put it? Super specific to the language that it is meant to compile. So this has a couple of advantages. The first off is that I can very quickly iterate the grammar of my language. So if my language looks like this, but I want to make it so that variables are now declared like this, all I have to do is just edit the... Actually, let's do it as a little bit of a test. Edit this rule. It's now going to be identifier. I don't even need identifier. Just the word var, followed by the identifier name, followed by colon, followed by the type. The rest stays the same. All right, so if that works, I should be able to make rules, which automatically updates the rules.c, and then I should be able to compile my language, except I'm not. What is the problem? It says found a problem on character 6. See, it doesn't tell me what the syntax error is, it just tells me, hey, you have a problem here, and I don't know exactly what it is. Var name colon type equal var name colon type equal... that looks good to me, just in case. Well, no, that should work. All right, how do we know? Really, the best way to know why it failed is actually to just turn on debug printing and reading this. And that should tell me exactly how it failed. It tried to parse a block, a statement, a declaration, var y equals int. Oh, no, hold on. Var y colon int equals, then 0, but it failed to match the next thing, backtracked. Parse token, and then it parsed the semicolon. And now it worked. Whereas if I put all of this in, it works. That's weird. Did I not recompile before? That's pretty much it, I'm pretty sure. I just didn't recompile. I just ran this. Yeah, that's that's the big problem. All right, so trust yourself a little bit more. And yeah, if I want to change the syntax of my language from the usual C style of declaration of a variable to this one, then I can very easily do so by just changing this, recompiling the rules, and recompiling the project. Very important, recompile the compiler, otherwise it won't have the new rules. Shocking, but yeah, sometimes we forget. Now, sometimes you forget, I never forget. So it has that advantage, with the disadvantage that when there is a problem, it doesn't really tell you what the problem is. It doesn't really tell you where the issue was. I can technically make it a little bit better at debugging. Since right now the way that it tells you, you know, the error happened here when I didn't recompile the old rules, well, the new rules, and I was running it with the old rules, and it was like, hey, you're not supposed to have this symbol here. It knows that this is where the error happens, because as it tries parsing, it tries multiple options, and one of them gets further than the others, the most correct one, if you will. And there it tells you, it records that point. I got this far, and that's how you know that that's where the syntax error is. You could possibly also record what it is that made it fail, and when you do that, you can probably then know what the error is. So I'm gonna see how difficult it would be to do that right now. But if it is even a little bit difficult, I am not going to bother with it. So the furthest pause is pretty much just being set here, I'm sure. Also here. This is where it says subrule failed. And then option failed. Yeah, so it's not super easy for me to do, because I'm not keeping track of what it is that failed exactly. So I'm not going to bother with that. Again, today I want to do code generation. So, like I said, the advantage of that is I can easily iterate on my language. The disadvantage, I don't have a whole lot of information on what went wrong. But let's experiment. Hold on. Can you restore? There you go. Now it compiles again. All right. Last time when I did semantic analysis, I realized that basing it off of the rules being in a text file makes it really difficult for me to do semantic analysis, because it doesn't really know what those rules are and how they look, because this is all being declared inside of this file, and I can change it as easily as I showed before. Then I can't really hard code the semantic analysis rules. Like for a declaration, the first one is the type, the second one is the name, because just now I inverted them and you would have to change that manually. So I added this little tagging system where you declare, oh, well, you don't declare, you tag each element that you're parsing as what it is supposed to represent, and then you can still do semantic analysis on it. So this identifier over here is the type of the variable that is being declared. This here means variable declaration. This here means this is the type of the variable. This here means it's the name of the variable. Whereas other tags like this one check that the types are correct. These are for type checking. I'm not really using them right now. I'm just checking that any variable that you try to use exists, but that's about it. Any variable or any kind of jump. Besides that, I should also be doing type checking, which I'm not doing. But for example, when I say identifier at jump over here on the right side, that means we expect to find, this is a go-to of some sort, and we need to know where to jump to. So somewhere else, a label must be declared using this rule that explains how to declare a label and its name here. And I thought about it, and it turns out we already have somewhat of a canonical representation of what the code looks like. Not really. That's not super accurate. Let's say... Also, when I was getting my headphones earlier, I noticed they're like tangled, and now I feel like fixing that. So I'm gonna do that while I talk. I have a system for any syntax that you pass in can easily be translated into a, yeah, let's call it canonical form that the compiler always understands. So kind of like an intermediate representation, which compilers rely a lot on. For your compiler to be able to generate any actual executable code, to do any kind of useful analysis, all of that stuff, then you want it to kind of have this internal representation of the code that it itself understands. Does it matter if the code that you wrote as the user, you know, writing in a text editor, is it C? Is it C++? Is it Rust? Is it Objective-C++? Please don't make it Objective-C++, but hey, is it? Well, that doesn't really matter to the compiler at this point, because it's parsed it, analyzed it, and turned it into an intermediate representation, which it then can do other things on. Optimizations, more analysis, all of these things. And these tags actually really help me do that. Because this... Hold on, how do I... Why is it not working? What? Because I'm pressing the wrong key, okay. Well, hold on. What I have selected right now is what you write in the code. And what I have selected now is what the compiler sees in terms of meaning. Right? So again, I can change the syntax, and as long as the tags are somewhere, it knows this is a variable declaration, this is the type of it, and this is the name. And it can even eventually do this to check the type of the variable. Right, so it will be able to evaluate the expression to make sure that this type matches this type. But we're not going to make it this complex just yet. But the cool thing about it is that this here is essentially the compiler's internal representation of the code, internal intermediate representation language. So we can use that to create this intermediate language. And actually, this is where my compiler stops, kind of, for the time being, which is that the intermediate representation is going to just be structured like C code, because the point of my compiler isn't to produce an executable, it's to produce C code that then gets compiled by GCC. So right now, this intermediate representation, it's going to be held probably in some sort of internal data structure. I haven't really thought about how to generate it, to be honest. But yeah, probably some internal data structure. But then you can print it to text, and that should be C code, because the point of it is to generate yeah, C code that then GCC can read and compile into an executable for me. Also, any more complex type checking, even basic code analysis, GCC will handle. Okay. So that's kind of easy, let's say. But I guess I need to find a way to make my code generator a little bit smarter, to understand these tags, which are already in the rules and they're already accessible to it. It just doesn't do anything with them because they didn't exist when I created the code generator. And that way, instead of just generating code based on these rules, so essentially generating the same code that it gets as input, it will generate code according to its own rules. In this case, it's going to be C code. But actually, an internal representation of its own code and then C code. Okay. So that way, it just won't rely on these grammar rules anymore. Grammar can go back to baking, I guess. Or knitting, or whatever she does. Okay, so funnily enough, when I built the semantic analyzer, I based its structure off of the code generator because both of them go through the abstract syntax tree that is generated by the compiler's parser and then do some sort of analysis on it. And now it's time to give back. So what I expanded this one on now becomes this one. Right, so we still go through each of the rules of the language, still switch the rules, and analyze rule just calls itself because it's a recursive function. It looks at the action that is currently declared. That's what it cares about. Okay. So kind of this is what I need. This is just indicating what action is to be performed, this one. Which is goes here. But you don't generate a symbol. Instead, we just keep track of the current action, which is type. There goes Clang not working again. The type of it is semantic action. Semantic rules. I said I was going to change these kind of misleading names because a rule is an action, but then there's also a semantic action type, which is a different thing. So, are we sure? Semantic action is non-declare or check. Ah, I see. Yeah. So maybe let's not call it a code action. Let's call it a code, let's call it a statement type. Right, so that keeps track of this. And then what does the analyzer do? It is kind of yeah, it's kind of hard-coded to look for a type and a name. and then just put those in the symbol table, so to speak. And then generate them. I'm not sure that's even necessary. Really, what I should do is let the symbol table itself allocate space for these local variables, I guess. But not really, not really. Because this is, we're generating C, not assembly. I'm thinking about generating assembly, so maybe, let me not get ahead of myself. All right, this stuff is kind of what I need. Right, which goes here. Also, I'm not sure why this print is out when it's printing an error. But, all right, let's keep it. All right, so let me see what it does. I don't think we need to do anything when there is a semantic symbol telling us to check something. That's not important. Right now, all I want to do is output a variable declaration. Right, so as always, I'm just going to do it in code. I mean, in just prints for the time being. It's the editor is Z, and vibe coding is forbidden. Also, definitely not entry level, I would say. All right, I'm just gonna hard code just for one statement type, which is variable. Right, if that's the case, then we are creating a variable. So declaring variable. Then here and here, I just want to print the type of the variable is whatever we find in the token. And the name of the variable is whatever we find in the token. Literals are still being output in the same manner as before. Maybe we don't want that anymore. And here we do want you to just output a token. Okay, so let me see what that does. Okay, I gotta remember to recompile. Okay, it's outputting semicolons, which is not supposed to. Code generation is in like the compiler's code generation, not that I'm having my code generated. Okay, this is actually so hard to understand now, but kind of. My compiler now understands it is declaring a variable of type integer called y, a variable of type integer called x, and here something of name y loop and something of name x loop, because I haven't told it yet about that rule for generating labels, but hey, good for you. Let me tell you about it real quick. If it's a jump, then now you understand. You're declaring a variable of type int called y, declaring a variable of type int called x, declaring a label type y loop, declaring a label of type x loop. Oh, not type, named y loop and x loop. So it is kind of able to generate these parts of the code, which are just the declarations themselves, it doesn't really understand any of this code yet because none of it is really tagged in any manner. So I probably need to make it have those kinds of tags as well. For example, a function call. Hold on. Which one's the easiest for me to expand right now? I'm gonna have to make some changes to the tags because I'm gonna need to add more tags, and I'm also going to need to make some changes to them. For example, this one that says jump is no longer gonna be a jump, and also it's gonna be a label itself. It's gonna be called label straight up, and this one should be check jump, right? Because yeah, I'm not so sure about that. No. Jump is fine. Jump is fine. Jump is more than fine. And as a matter of fact, I can just get rid of this. Although type is wrong. Not sure where you're getting that from. Except that's probably, yeah. There's no none, so type is 0. It used to be 0, now it's 1. So it defaulted to type, which is not quite correct. Okay, that's better. It is able to understand that we're declaring a variable, type what, okay, everything that I said before. And then it understands there's a name draw, type X, type Y, type X, X, Y, Y. That's wrong. Not sure why it thinks it's a type. But I'll probably need to refine the rules a little bit. Then it understands there's something called printf. Cool. Now, what I was thinking of is instead of using this, I just immediately use the name of the rule. Right? Because based on the name of the rule, I should... Yeah, I'm trying to switch rule, but not the function switch rule. These names, block, statement, assignment, function call, argument, conditional, declaration, jump, label, and expression, these are actually hard-coded. You have to use those. And so I might as well take advantage of that. They already declare the type of function that it is. So I might actually be able to get rid of these tags on the left side. I might just leave them on the right side, but not on the left side. They might not be necessary anymore. Because declaration, the name declaration already tells me that we're trying to declare a variable. But I can just do actually gen true, right? And I can just switch between these. Okay, what code do we generate when we have a block? Right now, none. So we get rid of it. When we have a statement is actually just any kind of rule. We generate code when we have a declaration, an assignment, a function call, a conditional, a jump, or a label, but not the statement itself. So that one we can straight up eliminate. When we have a declaration, we do generate code. And again, right now, the only way to generate code is just a little print. Maybe with a break would be nice. Expression could be a tough one. But not really. Then calling a function, argument, conditional, jump, and label. Everything that isn't included here is kind of irrelevant. We don't generate any code in that case. Right, and we don't generate any code in that case, which is why I created that gen variable before, where we skip all the code generation. Okay, yeah, look, expressions and arguments right now, there's a lot of them, and they kind of make this hard to read, considering it's literally just yelling at me, pretty much. So let's get rid of them for the time being. Okay, let's see what our code is doing according to our compiler. We are declaring an integer called y. We are declaring an integer called x. We're not doing the variables yet, the inside, the assignment. Right now I'm assigning them to 0, but yeah, still. We are generating a label called y loop, a label called x loop. We're calling a function called draw. The arguments are not really included here. We are assigning a variable, x. We are generating a conditional. Well, we have a conditional, essentially. We have a jump inside the conditional. We have an assignment after that. We have another conditional, another jump inside the conditional, but still a jump. And we have a function call to printf. Cool. I skipped a lot of the things in here, but yeah. Okay. And again, I should really get rid of these on the left side from the semantic analyzer as well, because they're kind of just redundant in a way. But I'm not entirely sure they're redundant. Shit, I'm not, I don't know. Maybe I'll just make them optional, but I'll keep the code as it is, because it's still useful. Maybe in the future I will need them to create a new rule that isn't a block, but still acts like one. But in that case, I'll have to hard code it. All right, now I'm thinking about refactoring the code that I haven't even finished yet. So let me not bother with that. Also, Restream is now advertising that it made AI clips out of my streams. Wow, thank you so much. I looked at one of them. It made a clip where you can't see anything happening. Not because it was like super complex. It was literally from the Hightail stream yesterday, where literally something was happening in the middle of the screen, but for some reason the AI in its infinite wisdom decided that it needed to show the left side of my screen where absolutely nothing was happening. It was like, that's where the action is. So yeah, now they're advertising that they made this really shitty thing to me. Thank you so much for that. Anyway, even if I ignore the left side tags, I still need the tags on the right side to understand how this is being done. For example, the function call. Yeah, here we have it. But here we have the name of the function. Great. That's how we know which function to call. And if we look, we're calling a function called printf. So the compiler understands that, and it will be able to generate C code based off of this. But it doesn't understand the arguments, for example. So I will need to tag this so that it understands you're supposed to generate arguments based off of these functions. But even then, you kind of get it because these are here. Yeah, so maybe that's not. I'm a little bit confused as to how this should work. I feel like if I do this correctly, in the information that I'm printing, I should be seeing the all the information that I need to recreate manually, in my head at least, the code, right? Because, yeah, I have it, but it's not super useful, but I can still do this. Even if I'm generating it manually like this. A label, oh, easy. I know how to generate that one. I just put a semicolon at the end of it. Another label, again, easy. I know how to generate that one. I just put a semicolon. Calling a function named draw. Cool, but I don't have its arguments. For that matter, I also don't have this. The information there. I'm assigning something, but I'm not being told what or how. So this needs more tagging. Okay, that's a useful one. Assigning identifier name. This has to be the name of the variable that we're assigning. We're giving it some value. So if I regenerate the code and I just do, no, that didn't work. Wait, hold on. There we go. Okay. And doing this part manually, eventually the compiler will be able to do it itself, but just to check correctness, I am assigning something to X, but I don't know what it is. I also don't know what goes inside draw, and I don't know what the initial values of X and Y are. There's a conditional, but I have no idea what's going on inside that conditional. So what's going on here? I have no way of knowing that the jump is inside the conditional. I know that because I wrote the original code. The jump is inside the condition, but currently I don't see that. And again, another assignment. I'm assigning to Y, but I have no idea what it is. Another conditional where I have no idea what I'm assigning to it, or what the condition is, or what happens if the condition is true. Another jump that I don't know that it should be in here. And again, calling printf, but no idea what goes inside of it. All right, so ideally I don't have any of these question marks. That's what we're trying to get rid of. And that's for me parsing the code or generating the code manually based off of this. It's probably going to be even harder to do it automatically entirely, but that's what we're here for. Okay, I did skip some, specifically, any kind of important thing happening here. And also, when it comes to the block, that one should be able to tell me that this goes inside here. right? So I can do something like this in order to indicate that we are at the beginning of a scope. But it's not, no, it's not accurate in the slightest. So let's not do that one problem at a time. All right. So the declarations. Right, I forgot. I need to do the code knows that there's an expression, but it doesn't know what to do with it. So it just says int y equals some expression, but we don't know what that expression is. The same thing happens for x. I'm not going to do the whole thing every single time, so I'm just going to skip through that. Labels are already done. They're very simple statements, so they're very simple to generate as well. We're calling a draw function with some arguments, but we don't know what those arguments are. Those arguments are actually have an expression inside of them, so there's that too. Wait, are these the arguments? Oh, hold on, no, hold on. Wait, hold on. We do kind of have this information. Argument expression x. Another argument after that, expression y. And another one that is actually hard-coded, so we don't know what goes there. Cool, but hey, we almost generated the draw function. We are assigning to x an expression of type x. Actually, we are able to parse that with some symbol, some operation being done between x and another expression that we don't know anything about. We know we have a conditional, and that condition is x, some operation, some expression. We don't know what it is. There's a jump. We don't know where. The rest is pretty much the same. All right, so not a bad start. Not a good start either. And the three types of semantic value are a type or a name. That's it. But rules, here you are. Type, name, but sometimes there's also jump, name, var. So instead of this, let me just do that. Okay, that's some more information that we already know should be there. I'm just not classifying it in any way. But, hey CMD. Consts are not being generated because they're not being checked in any way. But anyway, int y assigned something, int x assigned something, label, draw x, y, something, x assign to x, x, and something else. Not too many bugs. No bugs. I'm just trying to figure out how to do this thing properly. But yeah, no bugs actually. But for example, what we did learn from this is we're doing a jump to while loop. So that one's very easy for me to generate as go to while loop, right? That I understand pretty clearly. And there should be another jump. Same thing happening here. Go to X loop, and those jumps are actually being declared here as labels. Which I can just get rid of this. Put them like that. So, okay, that code we're able to somewhat generate. But the one we're still not able to generate is constant expressions. But here I have to be careful. Only this constant expression need to be printed. Whereas, where am I using other consts? Nowhere else, actually. But either way, and just tag them as val. And the operators as OP. So I'll need to create those two. Gotta keep track of all the new tags that I'm adding. Yeah, so an expression can be between a value, operator, another expression, or a variable, operator, another expression, or just a value, or just a variable. A jump can be to a certain name. No, this is a label. So a jump can be go to a certain jump name, and then a semicolon, but we can skip that if we want. A declaration takes a type, a name, and an expression. A condition takes an expression and a block. An argument has an expression and another argument, or just an expression. A function call has the function and then arguments inside of it. An assignment has a name and an expression, and then that's it. Okay, so I created these two new ones. I'll implement them after the ad break, so I will be back in 3 minutes. Okay, ad break is over. Playing whack-a-mole with some bugs in your script. I was doing that yesterday, which is why today I can do development. That's great. Okay. During the ad break, I realized that I should also tag these kinds of things, like for the conditional to know where the actual condition is and where the scope is. It's done with this, so great. Great to have that. Probably should make it a little bit more explicit as well. For example, when you're doing an assignment, this is the name, this is the value. When you're doing a function call, these are the arguments. So don't just rely on the fact that this is an argument rule, but yeah, actually explain that these are arguments. So yeah, what I said before about the name of the rule already indicates the kind of thing that it does. Let's forget that. Let's forget that. That's not how it currently works. That's probably not how I want it to work. Okay, so let's just call this one a call. We already know it's a function call. An argument, a conditional, jump here, jump name. Okay, I'll have to refine these a little bit more, but var func jump scope. Also these new ones. Value, operand, condition. Not really call. Call doesn't go here. Call goes... Kind of forgot. No, it does go here. It does go here. Okay. So with these new rules, if I do make rules, unrecognized grammar token. So I did something wrong. Most likely, yeah, it's the new line. Great. Because it's new line sensitive. Having two new lines at the end actually fails. One new line is fine. I don't use C++ because it has... It's a little bit too much hidden complexity for my liking most of the times. I'm gonna keep this file open for next time I do this thing. But... Alright, we generated rules. Are we able to compile? Yes. But we find a syntax error at position 9. So what changed exactly? First off, where did my project panel go? And this used to be an identifier, but it's still just a token check. That's okay. This is a semantic rule. We're now checking that, or indicating that this is a call. That's okay, but we're not changing anything. Const. Operator, yeah, that's fine. Operator stays as operator. And const stays as const. So, in terms of parsing rules, nothing should have changed. Even though I did change, for example, token to sim declaration name, simdec expands to this thing right here. 0 tuck identifier. Can I copy that? Yeah, perfect. All right, expands to that. Then you can just do token identifier, and that expands to this. So the parsing rules, which are these two, stay the same. This stays as identifier, this stays as 0. This stays as 0. These are semantic rules. They change. I don't care if they change, because those are semantic rules. Whereas it says that it found a syntax error on line 9, which is a little bit concerning. So I already checked that all the rules should still be the same for the parser. Maybe semantic analysis could have broken, but I'm very surprised that syntactic analysis broke. So time to whip out this bad boy. And okay, so it still happens here. We can just read what's happening here. Okay, statement, declaration, int y equals. You fail to match an identifier. You find a const instead. You fail to match an identifier. You find a const instead. Fail to match an identifier. Fail to match an identifier. That's not right. It's trying to match an identifier 4 times in the expression. Const operator, that's not... Oh. Sim check. Okay, I see the problem. This name is not being used anywhere. It's supposed to go here. And this name is not being used anywhere. It's supposed to go here. All right, so I did break syntactic analysis in that manner. It says that 0 does not exist because now, yeah, I used some rules that I probably shouldn't have. But that does work now, and I can turn this off since the parser is working again. But yeah, 0 does not exist. Why are you trying to check that 0 exists? 0 is a val, not a var. Not supposed to do that. So the semantic analyzer is saying does not exist. Oh. Because I made an exception specifically for func. Should also make an exception for val. And it's probably faster if I just indicate what should be checked for. If you find a variable, then you want to check that it exists. If you find a jump, you want to check that it exists. And this one I'm going to disable because there's currently no function declaration, so it's a little bit dumb to check if a function exists or not when we don't have a way to make it exist. But it should also check that the function that you call actually exists. And now it works. Okay. Cool. And now we have a bunch of extra information. First off, where's this done coming from? Oh, that's what's being printed. Right. So manually, I should have enough information to do the code generation by hand. let me see. I'm declaring an integer called y. So how do I generate that? Int y equals this expression, which is the value of it. Zero. Int x equals 0. I'm generating a loop. I'm generating a loop. I'm calling a function called draw with an argument of type x, an argument y, and an argument literal like that. I'm then assigning to x the following value. My god, I cannot press the right key. I'm assigning x equals x plus another expression, y. I'm then doing a conditional. Expression x is smaller than 100. That goes in here. I'm then doing a jump to x loop. I'm then, again, I have no way of knowing that this goes in here, but we'll get to that part next. I am then assigning to y the following values. Y plus this expression, 1. Hey, hard worker. Working hard or hardly working? Been waiting to say that one for a while. 10 seconds, actually. Okay, after that, we have another condition. Y smaller than 100. Just gonna go a little bit faster here, otherwise we're gonna be here all day doing this. We're then doing a jump to this label right here. We're then calling a function, printf, with arguments, done, and done. That's our code generated. Relatives have gone out of their home the past 4 days. Interesting, nice. All right, so we have enough information to generate the code, but I made a lot of assumptions. For example, yeah, actually, here. When I said that we're jumping to while loop, that's the scope of the if statement, right? But if we want brackets, where do we put the closing bracket? Do we put it here, which is where it actually belongs? Or do we put it here? We have no way of knowing that for now. Why am I trying to save a file that I shouldn't save? However, I did add some tags to the rules as well. So when I'm doing an assignment, I'm indicating that this expression is the value that I'm assigning. Right? So when I'm evaluating the expression, I can just say, assign this value to this variable. Easy. And I have to evaluate the entire expression, sure, but that is how I do it. So at least from generating code by hand like I've been doing, I should have enough information to do that. So far, I've been checking if an element has a rule. And if so, I just evaluate that rule and I don't do anything else. That's cool, but it's no longer enough. If the element has a semantic value, well then, begin Oops. And end. Can I print the name of the semantic value? I should have a printing function to print this semantic rules, sem rule name. What? Oh, wait, hold on. We're not evaluating any rules unless they have a semantic value, but we should always evaluate all the rules. All right, there we have it. Now I should have all the information that I need. Let me see. Nope. Not in the declaration anyway. Yeah, I forgot to put that in. Still no. Let me see. In a declaration, it still says rule expression. Oh no, okay. Damn. The parser is not really enabled to handle tags on rules. Separate compiler development into separate playlists. I think I've labeled all the streams as compiler development. Some of them were compiler and operating system, but they're kind of just compiler. So yeah, I'll do that. I'm not putting my streams on playlists anyway. Also, real quick, I just saw something weird with the title of the stream, so let me check that I'm not. Okay, category is software and game development on Twitch, and it's compiler generation. And on YouTube, it's compiler code generation. Category is entertainment. That's not super right. Then again, category is kind of useless on YouTube, but hey. And there, I fixed it. All right. Also, I realized my entire Hytale stream yesterday was labeled as software and game development. Even though I explicitly changed it, Twitch changed it back. Again, if I start complaining about if I start complaining about streaming software, I'm never gonna end. All right. Okay. I have to expand my rule generator a little bit so that if a rule has a tag, which I already have all the information that I need, I'm just not printing it correctly. If a rule has a tag, then I need to emit sim rule with the name of the rule and then the tag. Yeah, because the code generator didn't have that. Now it does. And now it says sim rule. The problem is there is currently no sim rule. Define sim rule with a name and a type. Should be the same as a normal rule, which is to say true to indicate that it's a rule. Rule underscore name to put the name of the rule there. Then its semantic action is really none if I'm not mistaken, but is that the one that I'm using for the check? Kind of need to see. I'm going to label it as none, and if that fails, I'm going to have to change it to check, most likely. Or even just emit, or actually just change the if statement. And then this sem type. Yeah, so it needs to be check because that's how we know that this is a type. I'll see if I can make it more correct by making this none. Because technically we're not doing anything in the semantic analyzer for this rule specifically. Although we should. Yeah, the semantic analyzer should still check the value of this, so yeah, never mind. Alright, make the rules. And now this is valid except for this one. This is not. Sem args. Oh, did I just forget to implement that one? Yeah, I forgot to implement that one. Alright, now we're good. Okay, it says begin and end, but I'm pretty sure I haven't updated the semantic rules name since I added more stuff to it. Excuse me? Where's this function implemented? Oh, I was looking at rule parser, not a rule helper. Okay. We need to implement a bunch of new ones here. Okay. None, obviously nothing to print there. Func is already being printed. Jump is already being printed. Scope is already being printed. Value. I don't think operand needs to be printed. I'm gonna comment it out. That's supposed to be operand. Conditional. Pretty sure you also don't need to print anything. So again, comment it out. Case call return call. Case args return arg. Okay, that's better. So I think now we have enough information to fully generate code, even if it is being done by a hand. Because writing a code generator that can actually hold all this information inside of it and then process all this information, we'll get to it. Maybe today? I don't know. But anyway, we are declaring a variable. Okay, so somewhere in our code generator, we need to know how we declare variables in our intermediate language. Or in our language that we're generating, in our case, C. So to declare a variable in C, we take the type, we take the name, we put an equal sign, and then we have some initial value to it. This initial value is being given to us by this begin val and end val. So everything that we find in here. It's an expression. So we have to evaluate that expression. We find a 0. That's the end of it. We put a semicolon at the end. We've generated the variable. I don't want to step through the entire thing for the millionth time today, so I'm just going to skip through everything that we haven't already done. All right, we have to generate a label. This one's super easy. We know exactly how to generate a label. There's no nested rules. We just have a name and a semicolon. Sorry, a colon. Same thing happens here. All right, function call. We're given something called a name. That's it. We are then given its arguments. Its arguments begin here and end here. So here's the end of our function. This we need to generate by just putting commas here, here, and here. And bam, we were able to generate the function. Okay. Assignment. We know the name of the variable being assigned. We know there's an equal sign because this is how our language works, C in our case. And then the value being assigned begins here, ends here. And it happens to be x plus 1. And once we reach the end, we know that our language has a semicolon at the end. Okay, we're doing a conditional now. Weird. This is empty. Oh, my. Oh, here. So condition does need to print something. I'm not going to restart, so I'm just going to check. Begin condition. Cool. End condition. Cool. All right. So we begin our condition. We do that with a parenthesis. And we end our condition also with a parenthesis. It has an expression. X smaller than 100. And then it has a scope. How do we begin a scope? With a bracket. And we end our scope here. And now we know that the jump that we find inside, which is translated to a goto, is inside of the if statement, which so far we really didn't know this. Now we do. All right, we assign, same as before, y equals y plus 1. Another conditional. Smaller than 100. We begin the scope, which is just a goto, this, close, that's it. And we have our function call printf, begin arguments. Argument expression, done. Done. And there we go. We've recreated the code. And this time, you can actually kind of do it in an algorithmic manner, which means that I will be able to write a generator that actually does this automatically instead of me having to step through the prints. But begs the question, how much can I cheat through it? Again, thanks to the fact that I know my language, I can get rid of all of these. Gen argument, get rid of that. This, put an if instead there. Jump, put a goto. And skip that. So that should make it a lot cleaner already. And then where I put those begin and end, I'll just put again, cheating a little bit here. The code generator. No, this should be, yeah, that. Closing bracket, nothing here, nothing here. I'm a little confused as to what I should put here. Maybe it's a colon. Nothing here. And on out rule start an opening bracket when we begin a scope. Nothing here. No, open parenthesis in the function, actually. Oh, okay. In the call, I put that. Open parentheses. Same for condition. Open and close parentheses. All right. So now out rule. Out rule start and out rule end. Wait. I did something wrong here. Again, I can kind of generate the code in a very cheating way, but hey, I can kind of generate code. Also, I'm not sure what I broke, that the equal signs are gone. Were they always gone? Oh yeah, they were always gone. Because they're not actually generated by the language. All right. Int x equals 0, while loop, draw. Where it used to say args. Yeah, that's missing. Int y equals 0. Again, the equal sign is not actually there, but we can put it in. Int x equals 0, y loop, semicolon, x loop, semicolon, draw x, comma, y, comma, this. X equals x plus 1. If this condition, go to x loop, this. Y equals y plus 1. Same if condition, go to this, and then printf done. Okay, so obviously that's not how you would want to do code generation. Because I am skipping a lot of stuff. Again, what I should do is now I have, thanks to these rules and thanks to these tags, not these, I have a internal representation of what the code is trying to do. So I read the code and read its internal structure. I analyzed it to make sure that it's all syntactically correct and in terms of type checking and whatnot. And now I was able to generate an internal representation of this code-ish, because I'm not super generating it, but I am able to do it. I'm not sure that I can help with beginner questions, to be honest. And from that, I can generate proper code. But right now, the code generator is more so an internal code generator, the intermediate representation. After that, once you have an intermediate representation actually declared, actually created, then you can actually generate code based off of pure data, not based off of any tree-like structure, not based off of any input rules that you got, just based entirely on the internal representation that the compiler understands of the code. Position vector of a game object. Describe the position of the object inside the game world. Okay. So that is cool. I believe that the compiler already has enough of an understanding of the... Well, I have enough of an understanding of the internal code structure to be able to build a thing that helps represent the internals of what the code is doing. What I don't know is how to actually represent it. And this is where we do a little bit of research. And my browser moved over here. So LLVM is possibly the biggest compiler backend. So the one that handles everything that I haven't done so far, but that takes as input this intermediate representation that it itself declares. And I'm just wondering what it looks like for them so that I can kind of recreate that. Is it really this? Okay, that's better, that's better. That's kind of what I expected it to look like. Then again, it kind of doesn't help that the if I want to look up what the intermediate representation of LLVM looks like, I'm gonna get text. But let's say 80% sure that it doesn't internally represent it as text, because that would be very inefficient. You would essentially have to parse it again, which I don't think is being done. I'm assuming they use some sort of internal structure. I'm assuming it's done in internal actual format, bitcode format, sorry. I mean, do I really need to make it this complex? I'm gone for 2 seconds. We're looking at LVM. Are you surprised that I'm looking at a compiler when I'm making a compiler? It is rare that I look at reference. I will admit that. But yeah. Also, the reason I don't look at reference is I have no idea what I'm looking at. I would have to read this entire thing to get a proper understanding of what I'm looking at. And I really don't want to do that. Oh god. Did I just download another Discord executable? Jesus Christ. I love that just keeping a URL open just downloads something like that. That's very normal. Oh, I already had this, which is a lecture on it. No, it's on their official website, so it's not a lecture. Hold on. Instead of using an LVM for this, I can just look at what my code does. I can just look at the tags in my language. We have scope. We have an implicit assignment tag here. I'll probably have to call it a sign. Damn it. Call a function. Also, I need to create that one. I completely missed the assignment, which is also, it needs to do semantic analysis on that one. Because I can't do this. This is not JavaScript. We don't allow this type of thing. So even assignments need to do semantic analysis, but they don't need to do declaring in the symbol table. Instead, you need to check that the symbol exists. See you, goldfish. But I do think it's a good idea to declare. When are these used? In SimDeck, which is for like what? SimDeck specifically inside of here. How does this compiler know to use a SimDeck? Based on if it is a declaration. Oh, that's dumb. I'm working on a compiler right now. This is a really dumb way of knowing if something is a declaration or not. That's so dumb. That's so dumb. It does it by checking if it is type and name. So anywhere that I use the words type and name, that's a declaration. Anywhere that I use the words here, for example, that's a declaration. Nah, that's such a stupid thing. That's dumb. I'm gonna have to change these rules a little bit. All right. I keep wanting to shorten assign. I should not shorten assign. No, wait, this is argument. Assign was already there. Okay. So I now need to put these in as semantic rules. Var sem declare jump sem label and assign. Percentage for the compiler. That's really tough. It depends. I feel like every time you ask like percentage of completion, at least for me, the answer will always be it depends. The initial version of the compiler, I'm planning on having it just do well, the very initial version of it is just this, which is technically C, compiling to C. So, dumb as it sounds, it's used to test that the compiler works. After that, expanded to make my own language and whatnot, with kind of an experimental, not super optimized, not super descriptive and helpful compiler, but one that helps me quickly iterate to make a new language. And then after that, optimizing it, making it better, actually gearing it towards my language and not just towards experimenting with languages. That may even be a entirely new compiler, but yeah. All right, how do we know if something is a declaration? That should be a boolean. variable that is actually determined by the left side. You decide if this is a declaration. If you have a tag of label and deck, then that is a declaration. You have your tag, right? Okay, here. Slice literal match token to slice tag deck not case insensitive, or same thing but with label. This determines if is a declaration or not. Unrecognized grammar token. Well, that's wonderful. Wait. Double new line. Again. The compiler is not very smart like that. For that matter, even this is no longer valid. Okay. Yeah, this shouldn't be named. This should be var. Var. Is that the only problem there is? No, there's a bunch here. Sem lm val. Yeah, okay. Damn. These used to be checks. Why did they become declarations? All of a sudden, expression is... Oh, wait. Okay, rule parser. When I set this variable to true, and then I don't put a tag, it doesn't get reset. So I need to manually reset it. That should fix a bunch of those problems. Yep. All of them, actually. Okay, that's better. That's better. All right. So now, in an assignment... No, okay. Yeah, that's still wrong, though. Because the rule is wrong there. That should be var. An assignment should check that this variable exists, and then evaluate this as a value that is being assigned. Cool. Whereas a declaration should check that the type is correct, should check that the name exists, because these are actual declarations, and then should evaluate the value. Jump, label name. Okay. So now indeed the language properly, the compiler, I mean, properly understands. Wait. Yeah, like I said, that one's wrong. It's var. There. Okay, no more errors. And it compiles. Cool. All right. So now that I did it properly, I have essentially created a compiler's internal representation of the code. And it is able to generate it, kind of, ish. Code gen is gonna be to C, but we're not there yet. Right now, we're just generating a representation of the meaning of the code internally for the compiler to understand, to work off, and to do all those things. So it's intermediate representation generation, really. All right. So, like I said, what I want to do is I want to extract from here the internal representation of the code. So we have like scope. This is completely ignored. See, this rule here is completely useless when it comes to code generation, because all it does is just group all of these other rules together. It doesn't actually generate any code, and it isn't actually relevant in any way. No, not the AST. Not the AST. The intermediate representation. The AST is already done. Although it's a stack type of thing, but it's already done. Okay, an assignment is done with a variable and a value. That makes sense. A call is done with a function name and arguments. Let me just put here this. A scope generates nothing but what's inside of it, but it doesn't actually generate any code. An argument, again, generates what's inside of it, but it doesn't generate any code by itself. It should generate the comma. So maybe I should give it a rule for that. No, it shouldn't generate the comma. It's up to the actual code generator to decide how to do that. Because, for example, when you're doing assembly and you're pushing variables, you push them to registers or to the stack. You don't use a comma at all. 3 years in your degree. Well, they don't tend to teach. Well, actually, I learned how to do a compiler for college, but it's not super common. Did I not tag this one? This one should have been tagged somehow. As cond, probably. Right, so just gonna check. That's wrong, right? Because all of this is not supposed to be here. But it does compile. All right. I don't plan on using statement elsewhere. What do you mean? For the time being, the current grammar is what it is. Okay, so this one is a little bit confusing to read, but the compiler understands what's going on. A condition has a condition and a scope. That is a Boolean value that it checks. No, I did a full compiler for college. Kind of an optional class if I'm not fully mistaken, but yeah. All right. A declaration uses a type, a name for the variable, and a value for the variable. A jump, again, looks a little weird from the words that I'm using because I'm reusing keywords, but I understand what they mean. A jump simply has a jump. And having a block, for example. Yeah, I have block, which contains statements. That's a thing. Yeah, but I don't understand what you mean by don't plan on reusing statements elsewhere. I don't know what you mean. All right, then there's label, which just uses the name of the label. Jumps and labels are very simple. And then we have expressions, which are not tagged as anything. They should probably be tagged as values, right? So that the compiler knows how they work. Value. And this one gets a little bit weird. Oof. quite weird. This is where it all breaks down, because you got value operand value, or you got var operand value, or you got just var, or you got just value. Here can go any of these specific groups of statements. Yeah. That is what statement is. It can be a declaration, an assignment, a function call, a conditional, a jump, or a label. And they exist within a block, pretty much right now. The syntax right now is very minimal. Literally, all the rules are being used to parse this, which is just pretty much what I said. Okay. Expression is where it all kind of breaks down, because it suddenly becomes very hard to understand what is going on based on just these meanings. But for that matter, not necessarily. Yeah. Just because using the word val here and the word val here has different meanings. This is expression, really. This is expression, this is value, and this is var. It's not a useless group, just when it comes to the intermediate representation, you don't really need it anymore, because it just gets replaced by the actual statement itself, you know? Okay, so I am gonna do that. I am going to replace these add vals with add exp. And again, there's a high chance that what I'm doing here is redundant. Declaring things as both rules and as semantic rules, but rather be safe than sorry. Okay, there we go. Okay. So now my actual languages blanking on the word. This is the language that I'm parsing. This is the language that my compiler works with. If I wanted to make it an interpreter instead of a compiler, I could just execute based off of these rules. If I wanted to make it generate to C, then I just have to have a way of translating these rules to C. If I want to execute it in assembly, I have to translate these rules to assembly. If I want to do it in, you know, all that stuff. Expression replaces to val up exp. So val up exp would expand to val up, val up, val up. That's how it currently works, yes. Not sure if I'm gonna keep it like that forever, but that is how it currently works. It was just how it was easier to build it when I was building the parser, and so yeah, it works. Okay, there is an ad starting. So I will be back in 3 minutes, and I'll see, now that I have a language for my my intermediate representation, how to actually hold that information in a binary format that my compiler can understand. And actually, no, because those questions are super useful, because I need to myself understand what I'm doing. The thing about building something like this is you don't always know that it's gonna work. So far it has. I've taken a few gambles, For example, the syntax tree is not a tree, it's just a stack that I navigate as if it were a tree. And that way I can avoid, because the parser does quite a lot of backtracking and it's not super optimized, I can avoid a whole lot of useless allocations that I would be doing if I was doing a tree. The tagging system helps me keep the compiler very flexible, because literally I can change the entire rules of my language and what it compiles to just with this text file. Which actually yesterday I expanded to the rule parser that parses the file automatically writes to rules.c. So if I wanted to, in just one line in the terminal, I could just compile the entire thing. All right, I'll be back in 3 minutes. But the point is, yeah, I've gambled on these things and it pays off. It paid off eventually, but you never know, so questions are useful. All right, we're back. Is stack posing off as a 3 is the baking the traversal into the data structure or something? Okay, you left, to be fair, because the next message was Sia, but I'm still gonna respond to it. Essentially, it uses the same rules that it uses, that it declares here to do the traversal again. Essentially, when you find a block, It's like statement, declaration, identifier. So it pushes an identifier onto the stack. It also pushes like, we're now going into a statement. We're now going into a declaration. Oh, you're still here. Okay. Yeah, so we're going into a statement. We're going into a declaration where we have an identifier. We have an identifier. We have an operator. We're going into an expression. We have a const. That's it. So it... Oh, see ya, because I left. Okay, for the ad break. Got it. Yeah, so it has to keep track of which option was used to parse, whether it's this one, or this one. And I don't think it has to keep track of this, but I am keeping track of which element of the sequence it is. So this is the first one, this is the second one, this is the third one. It was necessary at some point while I was building it and ended up not being necessary, so I still kept it. Oh well. Anyway. Yeah, so I have a language for my intermediate representation. And did I use the word canonical before to describe it? It just indicates to the compiler the canonical... Again, canonical is not the right word. I don't know why I used it. But it just tells the compiler what the code does in a way that the compiler always understands. Because, like I said before, maybe I want to declare my variables like this. Or maybe I want to declare them like this. Or maybe I want to declare them like this. Or even like C++, for example, has auto. Which C doesn't, but not C99, which is the one that I use anyway. I don't know if newer Cs have it. It does have it. No, wait. Auto keyword in C indicates that a variable is local. This usage differs from C++, where the auto keyword lets the compiler deduce the type of a variable. Interestingly, although C++ is a superset of C, there is an exception in this case. Wait, so... what does it mean then? Never really did anything in C. It's a vestigial feature from an earlier language. It tells the compiler that a variable has automatic storage, but any scoped variable that isn't static is auto by default. So the keyword doesn't do anything. I see. And yeah, YouTube has quite a bit of lag on the stream. Twitch tends to be a little bit better. Auto is basically just useful for trolling. Yeah, but you have to still specify the type. But anyway, C++ has auto, which is essentially the same as I used var. Well, not really. If I used var here. I just say there's a variable called y, and then the compiler deduces what that variable is based on what it's been assigned to. So right now it's an integer. Right now it's a... whoops. Right now it's a double. Right now it's a float. And now it's a string. Right, so it just saves me having to specify the type. Either way, I started going off on a tangent about types and variable declarations that ended up specifying what it means. These are 3 different ways of writing the same thing, and your language might actually allow multiple ones of these, but at the end, they all kind of translate into a single thing, which, you know, can look like anything you want. In my case, it just looks like type name val. So actually, it looks like this. but not really, because we're not really generating code. I mean, we are printing it because that's the only way that I currently have to like visualize what's happening and to even store it somewhere, because I'm not storing it anywhere. But it's not even that it prints this way. It's just that it holds this information: type followed by name followed by value. Right? Maybe you can serialize them into a binary format like that. For example, the point is, yeah, it's not really written like that, but it holds that information. So whether you wrote it like this, or like this, it always ends up like this. And that much simpler intermediate representation language is what we're going to be working on from now on. It's what you can build optimizations on. It's what you can build the code, the actual code generator off of. And it's kind of useful, essentially, to do a bunch of optimizations. Because like based on this, if I know that a variable is declared but it's never used, I can very easily check that. I am compiling to an IR, and most likely we'll be changing the name of codegen.c. Yes, because that is kind of misleading. The thing is that this file, until today, used to compile to the same, using the same rules. Again, the same traversal that I mentioned before. It was doing the same thing. And recompiling the same code that it got as input as the output. The format was a little bit weird, but it helps you see that, you know, the AS3 is correct. AS3? The AST is correct, even though that technically also was correct, but hey, whatever. It helps you check that traversal is correct, because like I said, I was working off a stack and not a tree. I wasn't sure if it was going to work. But compiling a language to itself is not a super useful feature, so that's why today I'm doing this. Also, yeah, I called it code generator. Even the stream, yeah. Might as well just change it. That way it also stays archived with the right name. There we go. All right. And yes, the language is called CRED. For the time being, I'm not sure. For that matter, the compiler is... well, no, not the compiler. All right, just gonna do a commit of everything that I did, because I've been working for quite a while and I haven't... See, so these output literals, these are gone. Hold on, let me just take a quick look through the code here. Get rid of that. See, this is the actual like thing that traverses the tree using the language rules that it got. Okay. Okay, this is the one that generates just a basic kind of understanding of the language, but it doesn't really... You know what? Let me get rid of these. It was way better when I was doing sem rule. Whoops. Name. Yeah, it's picking the traversal order. My main goal was to make it be able to do as much as possible from just a text file, essentially. That way I can quickly alter the language. The point is to design the language, so. Bye, MX. Alright, bring these back the way that they were. Hold on. Get rid of that. Get rid of that. Yeah, Twitch should be better. Okay. So something has happened to my symbol parser, by the way. So I'm seeing that it doesn't have the variables being declared anymore, because I changed the type. And I need to fix that. But the code here is fine now. Okay, in the semantic analyzer. Yeah, the action is in no longer being assigned. Sem assign, sem call, sem cont, sem dec. The parser generator. That is why I wanted to do this. I don't use a proper parser generator that makes a parser like that. It's just, again, generic so that it works off of this. Which is why it doesn't have very good, first off, very good optimization. And second, very good error messages. I kind of thought of a way that I can make it have error messages, but yeah. Very much so, this compiler is for playing around and creating the language, not for actually compiling the language. It's kind of a prototype language compiler, I guess. There's this compiler here, well, I guess this works like a compiler, which is why I compare the two. Every C file on here is for the main compiler except for rule parser, which is the actual generator for the parser. But what it generates is this array. And then this array is being used by the compiler. By the parser, I mean. This one is doing things in a much more correct way. As this one specifically looks for like explicitly looks for an identifier, for example. And if it doesn't find it, that's already a problem at the very beginning here. So if you put a number, that's a problem. Yeah, that one's single pass. Then it looks to see if you have a tag. It parses that tag. Then it parses the actual rule inside of it. All of that stuff. And again, if you do something wrong, it can tell you exactly what you did wrong. It doesn't keep track of where you did it, but it does tell you what you did. And honestly, this is small enough that you can kind of understand it. But changing it is a pain in the ass. So when I added these tags and I had to change it, it took me a lot longer than just editing a text file. Yeah, it's the parser for this, which is self-generates the rules for the parser for the compiler. I need to create an OS for a real robot using C++ and Raspberry Pi. Do you have any ideas? You need to create an OS for it? That's kind of... sounds like a lot. Yeah, so let me see if I can explain the entire process. So you start out with this text file, which indicates on the left side of the @ the syntax that the user is going to be writing in their code, and on the right side what it means to the compiler. So it started as kind of BNF adjacent syntax, but now it's just kind of that plus tagging. So this gets compiled by this, which is handwritten, and changing it is a pain in the ass. But yeah, it is handwritten, and it is able to parse this and generate rules based off of this. The rules look like this. It's just an array. The parser then goes through this array, starting at rule block. It always starts at block right now. Eventually, probably kind of have to change. It starts at block and it generates... Well, it tries to check first this, then this, going inside the rules when it finds them, or trying to parse tokens when it doesn't find them. And there's quite a bit of backtracking. It's not super optimized, but it works. And actually backtracking, I had to fix... I essentially just rethought of the logic of it yesterday so I could do it properly, because I realized there were a lot of bugs related to it. All the parsing bugs that I've had were pretty much related to backtracking. This also encodes rules for how to do semantic analysis and IR code generation. So with just this array, the compiler is able to do everything. But, for example, when I have a mistake in my code, it tells me that it found a syntax error at position 30, but it doesn't know what the error is. And also position 30 because it's it doesn't count new lines like that, but 30? Hold on, why 30? See, it's not super accurate. Not sure how you were able to parse this correctly, but eventually it realized that it was an error. So yeah, it's not super accurate. And even if it tells you exactly where your error is, it doesn't tell you what the error is. But it is good for prototyping. Yeah, I do want to calculate a line colon offset. I'm not super interested in that right now, because honestly, I barely touch this. Once I have the proper compiler, I will. Once I have everything built. Right now, I don't. So this is like the least of my problems right now. Jester. His favorite pastime is licking himself, I swear to God. I should just play music on stream so I can have something else to listen to. Because it's either my voice or just licking, and yeah, it's a little bit distracting. Okay, actually, not gonna lie, I want to see how far I can take this compiler architecture without making a proper compiler, but eventually I do want to make a proper compiler. Like, yeah. And actually, once I have a better code generator, hold on, this is a thing that I did last stream that I did. This was Sunday, I think, that I worked on the compiler. And I checked, can the compiler compile this? And the answer was no, it couldn't, because of a backtracking bug. So now the answer is actually yes, I think. So we're gonna check. But before that, I have to check a bug in the semantic analysis, because it uses the sim type based on the action. And then it checks if it's a jump or a var or a func, but that's not right. Remaking Bison. The funny thing is, the first compiler that I made was just this because it was just for college. And now I'm doing it just for fun because I like doing things from scratch. So I've never even used Bison. That's the thing. I would have had to learn how to use a compiler, a parser generator. So I was like, yeah, I'm not going to do that. I'm just going to make it myself. I know how to make a parser. I know how parsers work. I don't know how Bison works. So probably easier to do it myself. It took me like, what, 2 days? All right. Semantic analysis creates a symbol where in a label and a declaration, not in a jump and not in a var anymore. And also not in a func. I mean, yes, but we currently don't have functions, but I'll keep that there. That's useful. Handwritten recursive doesn't parse you. It's either you learn how to do it properly or you just do it the way that you've always been doing it and it's been working for you. All right, so the symbol table is fixed. Now I have these symbols here. I don't have a concept of a block in it yet because there's barely blocks in my code. So, I mean of scope in the symbol table. I haven't bothered with that, but I will. But everything's good, and I can now do a commit, including this, which is my IR. This. Okay, I uncommented this out. Yeah, that's correct. Get rid of that. Stage this. Stage that. Okay. Let me change this to the rules, to the rule generator, and to the... Wait, hold on. One more thing I need to do. Code gen become IR gen. Codes gen become IR gen. Code gen become IR gen. And main code gen becomes IR gen. Cool. Okay, so we can print logic for intermediate representation. What did I do in the rule parser? Fix sim.deck logic, and in rules added can IR rules. I keep calling it canonical. I'm not sure why. Do tags. Commit and push. Cool. So yeah, I'm not gonna get too stupid with this. I was thinking, can I get rid of can I make the IR generation the second step? Can I get rid of the AST altogether? Right now, yes. But that probably won't scale. Hell, the current solution probably won't scale. So that's not great. All right. For the actual generation, or for actually holding the intermediate representation code, I'm going to wait until I understand a little bit more how I can possibly represent this, though I do have a vague idea, but again, not super standard, I feel like. And I keep getting these ideas of doing things in unconventional ways and thinking that they're not going to work, and then they end up working. And that kinda is scarier than if they didn't work. Because if people do things one way, and then you do things another way, and it doesn't work, your conclusion is very simple. It's just like, oh, this is why they do it that way. You start doing it that way too. Amazing. When people do things one way, you do them another way, and it works, it's scarier. Because then, technically right now it works, but will it always work? And how long until it breaks? If it breaks at all. That's the scary thing about doing things in an unconventional manner. You're like, at some point, I may encounter a game-breaking issue, something that just prevents me from moving forward. I will crash into a wall, and I'll have to start over entirely. Whereas if you do that and you crash against the wall really quickly, you're just like, yeah, okay, that's why people don't do it this way. Got it. But when it works, you never know. Okay, when you hit the wall, you know there's a wall. When you don't hit the wall, you don't know if the wall is a meter ahead of you or a kilometer ahead of you or it doesn't exist at all. So, scary. But I guess that's why we're experimenting instead of just using Bison and learning how to make a proper compiler parser. Again, the fact that my parser, my semantic analyzer, and my intermediate representation generator do the same thing, the same logic. It's kind of interesting. All of them go through these rules and well, not really. They do two different things when they go through the rules. The parser tries to match what it's being given as input to these rules, and then the other two just use what the parser already did. So there's no backtracking in the IR generator, there's no backtracking in the semantic analyzer. They're much, much simpler. All they do is traverse the stack structure instead of traversing a tree. But besides that, it's the same. It's just, instead of using a tree structure, I'm using a stack structure. Now this is where it gets interesting with the intermediate code generator. But before we get to that point, like I said, last time I tried making the proper parser parse its own rules, which it failed at doing. These are the rules for it. I didn't include tags. I was debugging to make sure that it works. But I didn't include the tagging system yet, so there's no tags just yet. But yeah, these are the rules. And this is a little very simple test to see if it works. And it fails. Wait, it fails because this needs to be new line sensitive, and I added NL. Boom. It works. And it says expression assignment, expression assignment, expression assignment, expression assignment, expression assignment, because here I just reused the 4 names that I had before. So it's not super useful. But I guess expression assignment, expression assignment, expression assignment, expression assignment. Yeah, those names are hard-coded. The rule names are hard-coded. Even their meanings are not, but the rule names themselves are hard-coded. Do I even use them outside of... Yeah, not super necessary that they're hard-coded. The main reason they're hard-coded right now is that, first off, this parser here, the rule parser, is very simplistic. Well, now I saw that my compiler can actually parse its own rules, so I may even be able to get rid of this one eventually. Because again, this compiler is incredibly flexible. That's the point of it, is to make it flexible. So I may be able to get rid of these rules. And I mean to get rid of this parser, but right now it's very simplistic. It doesn't store any information, it just reads and immediately emits code. That's it. Because of that, it's very limited in what it can do. It doesn't even store the name of the rules, pretty much. Which is why I cannot make them hard-coded. That, and the fact that it's meant to write everything to rules.c. It actually has full control over this file now. This is a completely generated file. I don't even have to copy and paste like I used to before yesterday, actually. But with the limitation that these enums need to exist outside of there. Do they really? Do they really? I don't think they do. Because this rule name can also be auto-generated. Yeah, that's what I'm saying, that the enums, these enums could be generated, but the thing is, I was looking for them, right, in the code. They're not being used anywhere except for here, which is just being used to... Actually, this is wrong. This is using the non-canonical representation. This shouldn't be used in this. It should be using... well, I changed them. So it should be using the right side. So actually, yeah, these values are not being used outside of the parser. So they might not even be necessary anymore. In that case, I'll probably be able to get rid of the hard-coded rule names eventually. I'll probably try to do it off stream tomorrow. I don't care too much about it. It's just to make the compiler really as flexible as possible. This file can really look like whatever you want it to look like. But yeah, the rule generator is able to parse itself-ish. Ish, because when I did it, it didn't have the ats. And the parser also doesn't allow for optionals, which would be nice. But it doesn't. Which means that it is unable to do these things. Well, you have to be a little bit more verbose about the way that you express whether there's a tag or not. And also these parentheses as well, which are technically allowed, and these. So yeah, I would have to be a lot more verbose in the way that I define the language, but technically it will be able to parse itself. In terms of the parser not being buggy, I think we're there. There were some bugs with the backtracking yesterday, so I fixed it. Those bugs that have to do essentially with the fact that sometimes we were consuming a token and not actually using it. I don't even remember what it was, but yeah, anyway. It's just the fact that the first thing we do is get the next token. But whatever, it's fixed now. Okay. You go back to how you were, now both of you, because it's cool that you can compile your rules, but first off, you can't compile all of them, and second, you can't do anything with them. Yet. But it's where it gets a little bit crazy still. Well, no, actually, before I do anything else, I start thinking about how to properly represent this. This is entirely wrong. You shouldn't be basing it off the rule. You should be basing it off the statement type. The statement type, which is these guys right here. Okay. So it's not a declaration, it's semdec. It's not an assignment, it's semAssign. It's not an expression, it's semExp. It's not a function call, it's a semCall. It's not an argument, it's an semargs. Probably should have made it semarg, but whatever. It's not a rule conditional. It's a semCondition, cond. It's not a jump. It's a JMP. And it's not a rule label, it's a sem label. Cool, that should have changed nothing. Wait. Yeah, that should have changed nothing, except now it's correct. It's no longer using these hard-coded rules. It is now using the non-hard-coded rules. And this is where it gets stacky again. Because what I have here is, once again, for the billionth, trillionth time, a stack. Which I could use to generate an intermediate representation, or I could navigate as the stack that it is. I can very clearly define where this declaration starts. It starts here. Actually, you know what? Let me make my printing a little bit more descriptive by also printing I did create I need to finish this, but by printing this essentially. It's not super complete, I'm pretty sure. But it might be fine. Yeah, no, it's not. It's not super complete. Or it's not super complete, or I did something wrong. Hold on. This is one int, and one represents semantic rule. Deck, which is wrong. It really represents semantic element 1. So it really is just a matter of printing it like so. lm sem action equals semantic sem action declare. Then you print it as the type that it is. Otherwise, you print it as this thing. So you print it as a semantic action. Check. No, I did it wrong again. Not the semantic action, damn it. As the semantic element. I hate that all these have very similar names. I even tried to give them more understandable names to these functions and whatnot, but I found it a little bit hard to do. All right, this should be kind of easier to understand. This is very much a stack. One more time. The solution is always the stack. Stack-based compiler, let's go. Trees, deforestation. We're doing stacks. Pretty much in this sequential, I was going to say sequential sequence. In this sequence of things, of text expressions, I have a very clear explanation of what the code is doing. If I wanted to build an interpreter that executes this code, I could do it with this alone. I'm declaring a variable. So current state, declaring. I have a type for it, integer. I have a name for it, y. I have an expression, because after you declare the variable, you give it a value. Expression, value, 0. End of the expression. Oh, I forgot to put begin, end to say what they actually are, so that's not super helpful. Well, anyway. It should be... Oh, it's just, I didn't finish writing this switch statement. And since I want to do this properly, I have to finish writing the switch statement. None is not necessary. Deck var is already there. Assign exp func You're already there. Okay. Label jump is already there. Scope is already there. Val is already there. OP is not. Condition is already there. Call is already there. Args is already there. And this is scout. The reason I have different names, I used to have the same name for all of them. But that way, I don't know, I felt a little weird to do gaming on channel with that same name, even though I'm still gaming on my YouTube channel as well, but I'm not saving any of that. I have a different channel for that. So mostly that. On YouTube, I can have multiple channels where I do different things. On Twitch, I can't. So I do it under my name instead, which is easier. All right, that should be a little bit more descriptive. Yes, it is. I have a declaration. How does a declaration work in my compiler's language? There's a type, a name, and an expression. This is the type, this is the name, this is the expression. That simple. Declaration, again, same thing. So we're gonna skip it. I have a label. How does a label work in my language? It just has a name. Boom, found its name right here. Label, same thing. I have a function call. How does a function call work in my language? It has a name and arguments. Name, arguments start here and end here. I have an assignment in my language. It has a variable and an expression, which ends here. I have a condition. How does it work? There's a condition and a block that executes if the condition is true. This is where the condition begins. This is where the condition ends. This is where the scope begins. This is where the scope ends. Jump, how does it work? It just needs a label to jump to, and this is it. Another assignment, another conditional, and another function call. I feel like again, I can just, in the same way that I was able to navigate my stack-based code syntax that the parser parsed and then generated, I can navigate this stack-based code syntax and use it to generate code. Now, most likely, I don't want to do that. Here, most likely, I don't want to do that because now I have the, first off, the reason that the stack was super useful when it came to parsing is that parsers have backtracking. Essentially, you think what you're reading is something, and then you reach the end, and it's not. Which especially in my parser, the way that it's built, not super well, but the way that it's built, this happens a lot. So how do you backtrack if you're building a tree? Well, you remove nodes from the tree. And those nodes are probably going to be allocated in memory, and so you deallocate them. So you're doing a bunch of allocations only to then deallocate them, only to then do more allocations, only to then deallocate more. So I figured stack-based is a lot easier because you just have a pointer, it grows, and then you backtrack, you just go back. And that the stuff that was in here stays, but then it gets overwritten, or it just gets ignored. So stack-based is really cool when you have backtracking because of that. And then I was like, okay, I can build a tree off of the stack. But then I was like, do I really need to? No, I don't. So I don't do that. Here, though, I feel like even though I could technically go through this as if it were a stack, because it literally is a stack, again, I can literally go through it manually myself and just understand the code. Or I can write an algorithm to do it for me. Easy. In the same way that I did it for the abstract syntax stack, or ASS, I can do it for this stack. But I feel like I don't want to do it because that will probably just make it harder to actually do things. Now, the thing about the tree structure is it can change. It can be different. You know, whether you have I don't know, let's say something that looks, something that looks like this, or something that looks like this, this technically generates different trees. But you know what? The more I speak, the more I realize that it is the same thing. That I can just navigate it as a stack. There's a reason that, yeah, the acronym. There's a reason that even though this is not an abstract syntax tree, it is an abstract syntax stack. I didn't call it that. Because ASNode doesn't sound as catchy. Well, maybe too catchy. But yeah, the more I speak, the more I feel like actually you could just navigate this as a stack. Why not? But yeah, maybe not the best idea. So what I'm going to do is I'm going to end the stream and just think about it a little bit. And on Friday, come to a decision. And actually do this. But we already have a compiler's internal representation of the code, which is what I wanted in the first place. How the compiler actually stores that and what it does with it remains to be seen on Friday, but we already have it, which is what I wanted to have. All right, so very quickly, just going to commit this. Send. I did spell it right. Okay, I wasn't sure. And the other thing is... yeah, that's good actually. Push down automata. It feels like it, right? Am I crazy? I feel like I'm pushing this stack thing too far. Pushing, like you do on a stack. Is that a sign? I have an interesting C++ API for making compilers called Script2. Like you made it, or it's Hold on. Come to think of it, interpreted languages sometimes use a stack-based machine, right? So, isn't that the same? I have honestly no idea. It's either stack-based or register-based. So I don't know what that means. So maybe let's start a little bit of the investigation here. Stack and register. LR parsers pop smaller nodes from the stack, transform them, and push bigger nodes back on. Yeah. I blanked on what that means. Let me read it again. Yo, what seems like half of an LR parser with the stack. As far as I know, the only difference is LR parsers pop smaller nodes from the stack, transform them, and push bigger nodes back on. But that's not really... Wait, when you mean the stack, you mean the syntax stack, right? Because you're talking about the parser. So that's just generating nodes for a tree, essentially. Which I avoid doing, but instead I just traverse the stack using the same rules. Because I have that advantage. I'm able to do that. A proper compiler for my language won't be able to do that. Stack machine is a computer processor process virtual machine in which the primary interaction is moving short-lived temporary values to and from a push-down stack. In the case of a hardware processor, a hardware stack is used. Stack machines and stack push-down automata with additional load store operations or multiple stacks and hence are Turing complete. So it is kind of a thing that is done by JVM, for example. Yeah. The biggest issue with this is moving stuff around, essentially, which I am going to need to do eventually. If I want to do things like lambdas, for example, and I want to compile that to C code, then those could be just like static inline functions, right? Which is how I've been doing pseudo lambdas or function pointers in C. But they would need to... I feel like I'm going to sneeze. I didn't. All right. With something like that, I will need to move that code around. Which probably can still be done with a stack-based machine. It just adds complexity. But again, the reason that I'm saying, can I just make it stack-based, is that it already is a stack. I'm not creating a stack anywhere for that matter. I'm literally just going through the code in a hierarchical manner and just printing, and that creates a stack naturally like that, which means my code is already going through that same sequence of events, and in that manner it's already capable of doing these things, which is why I'm saying it's just a stack already. It's not that I'm generating a stack, it's that it's already a stack. The thing is, I wouldn't be able to just immediately output code. That's the main thing about it. It wouldn't be about immediately outputting code. It would be about yeah, I'm gonna think about it. It is stack-based, but I think in this case it would be better for me in the long run if instead of just being stack-based, I make it based off of an actual structure, holding the code in a binary representation of it that I can then alter. I feel like when it comes to altering it, stacks become a pain in the ass. So if you want to remove something from the stack, you either move a bunch of stuff or you leave a hole. And when you want to add stuff to the stack, you pretty much have to move a bunch of stuff. So yeah, stack-based. It is stack-based right now, but if I want to do any kind of code analysis, any kind of optimization, any of that kind of stuff, I shouldn't use a stack. All right, see what I meant? Standard way of doing it, my way of doing it, crashed into a wall, already realized why it won't work, so I'm not gonna do it like that. Kind of relieved, not gonna lie. For the parser though, I think we're good with the stack-based. Okay. For the semantic analysis and for the actual IR code generation, so everything that I've done so far, how will it scale? In terms of performance, not well, but we can do a little bit about that. In terms of will it be able to handle all the cases that I needed to handle in order to design a language before I make a proper parser for it and a proper compiler for it? We'll see. Okay, but that is going to be it for the stream today. I have a lot to think about of the actual binary representation that I'm going to use in order to continue from this point onwards to generate C code, to analyze the code, to do all of these different things. But it's looking pretty good that this weekend, most likely, I'll be able to generate some very basic C code, and I'll be able to start expanding the language a little bit, and I'll be able to start playing around with it and building my language instead of just building the prototype compiler for the language. There is a chance, for that matter, that this project, instead of being the compiler for the language, becomes a prototype compiler for new languages. And hell, we'll see how far we can take it. Okay. So, like I said, this is it for today. Thank you so much, everybody, for joining. I'm going to link my Discord in the chat. And I'm going to be streaming again Friday. I was going to say tomorrow, but not tomorrow. I'm going to be streaming again on Friday. And I'm going to be... Restream's showing some errors there, but I think it's good. Yeah, I'm going to be streaming again on Friday. I'm going to be doing the actual intermediate representation thing once I understand how it works properly. So I think here I want to look at some reference, or at the very least experiment a little bit. I'll see what I can do. Okay. So that is my task for today and tomorrow. I also have a pretty big pull request, I believe, on my operating system that I also need to look at. So I also have that. And bug fixes are going well, at least. Yeah, major network update. Added IPv6, refactor TCP stack, and various minor improvements. Yeah, so easy, simple little thingy to look at. Gonna take about a second. Yeah, the dog is mostly sleeping, so you don't notice him. Also, he's sleeping on a blanket the same color as him, so he's hard to notice sometimes. All right. Yeah, thank you so much, everybody, for joining. I will see you on